Thanks everybody for coming. I really appreciate each and every one of you being here. Okay, so the topic for today is revolutionizing developer productivity and the evolution and benefits of internal developer platforms. My name is Cora Iberkleid. I'm a developer advocate at VMware. So I'm going to give you sort of a general history, a little overview of how we got here, and then I'm going to use a particular product to give you an example of what an internal developer platform can look like. So, it's a clicker. Okay, let's get started. So, what is an internal developer platform, right? So this term, it's been getting a lot of attention recently, and I think sometimes it sounds like something new, but the point that I want to make is that we've actually been on a journey for a couple of decades now, heading towards internal developer platforms. So whether you realize it or not, I think you know a lot about what they really are. And we've been on this sort of journey in this evolution of trying to provide computing capabilities as a service. And that whole idea is really rooted in empowering a user with a simplified, self-driven, autonomous experience. So if we look back, we have infrastructure as a service, right? That's a great example of enabling people to provision core systems without the expertise or the burden of having to understand or manage, maintain the underlying hardware. And this meant that you could eventually create an entire data center really using self-service APIs. Now, when these capabilities were exposed publicly with a pay-as-you-go model, that's public clouds were born, right? And then suddenly, anybody could create a mini data center with relative ease in the comfort of their garage, I guess. And this leap forward was really monumental. And this, together with open source, really did a lot for democratizing the software industry. And in fact, if you're interested, this book is not new anymore, but if you're interested, I really recommend this book, The New Kingmakers by Stephen O'Grady, for a really inspiring account about this period in history. Now, this shift, bless you, facilitated and accelerated software development and innovation, but infrastructure as a service and public clouds as a whole, they really address operational needs, not developer needs, and this wide gap between developer needs and operational needs. So we called the effort to bridge this gap and simplify that DevOps, right? And in the early 2010s, we saw significant efforts to approach this problem from the developer perspective. And that's when platforms like Heroku or Cloud Foundry appeared, and they tried to simplify the experience for a developer to a simple CF push or a Git push Heroku. This whole idea was also cleverly summarized in this haiku: here's my code, run it on the cloud, I do not care how. Okay? And these platforms, they were and they continue to be hugely successful in simplifying the developer experience, but the ecosystem of integrations around these platforms grew slowly. It wasn't quite easy enough to sort of expand the selection of services that developers could work with. So a few years later, we had Docker and Kubernetes that turned the industry on its head. And Docker basically catalyzed the use of containers as a standard unit of work. And it accelerated the adoption of microservices as an architecture and of cloud-native development practices. And Kubernetes essentially redefined the APIs and the architectural patterns for self-healing declarative deployments, and it also ignited the widespread adoption of GitOps. There we go. And so these models were extremely successful, and they enabled what is now this spectacular cloud-native ecosystem that we have. It's often illustrated in this jam-packed CNCF landscape. But just like infrastructure as a service, containerization and Kubernetes really address operational needs, right? There's still a big gap between those and a developer experience. So the question is, what is this gap, right? What do developers need? and what should we be looking for in evaluating or building a developer platform. So remember that the trend is always towards a simplified, self-driven, autonomous experience, right? So when we talk about autonomy, really what we mean is the ability to create, to update, or to destroy a thing, right, in a way that meets certain standards and expectations. And so when we think about a developer, that thing is an application. And those standards and expectations can include things like reliability, security, resiliency, scalability. So to achieve this, right, to bring the abstraction level up to an application as the unit, that means that all of the layers underneath have to be automated and integrated with one another. And this includes workflows that test, build, scan your code, configure a desired state, and then make that state a reality, right? So ideally, a developer should only have to do a git commit, and everything else should be taken care of automatically. Right, that we don't want developers to have to adopt operational skills or switch context, right? Because that will detract from their ability to make progress on what matters to them. Just really git commit and move on to your next iteration, your next feature. So in this sense, Kubernetes is a game changer, right? Because it enables us to compose these kind of automated application platforms. So this is the first step towards a true developer platform. But it's not enough to just sort of pave the way to this and sort of like make a paved path to production essentially and simplify the use of Kubernetes. Developers also need, for example, feedback, right? Did my app pass security checks? Which environments is it running in? How much traffic is it getting, right? What's happening at the network layer when I see latency in my application? All this kind of information is important to developers. And a developer platform should be able to consolidate all of that information into one intuitive location, one intuitive portal, right? Developers shouldn't have to hunt this down across different systems. But it's also not all about what's running. Developers have to manage a whole bunch of other information, like documentation, APIs, source code location, ownership, and a lot more, right? So this information, if it's not well managed, it really can get messy very quickly, and it can get overwhelming. And the lack of it can also exacerbate duplication and tech debt across an organization. So it's also about a developer's relationship to their own body of work and their relationship with other teams across the organization, right? So a developer platform should enable developers to discover, to share, and even to contribute to information about all of the internal applications at their disposal. So this can have a really profound impact on developer efficiency, productivity, and collaboration, both for onboarding and also for ongoing development. And finally, a developer platform is an opportunity for education and for enablement. It should be the go-to place for developers to discover what is the preferred approach within your organization, right? So what is this golden path, as it's called today, right, to any number of developer concerns, right? It can be, for example, templates for new applications. It could be readily available mechanisms for publishing documentation or APIs. It could be a default path to production, any kind of pre-configured solution for observability. For any one of these challenges, it's a primary working solution that's at the ready with sensible defaults that codifies the patterns and the conventions that you want to encourage across your organization. I'm sure most of you have heard this phrase, make the right thing the easy thing. So I think, yeah, it's good in all areas of life. It's a positive thing. And I think that with a golden path and a developer platform, what we can do is make the right thing the obvious thing. Because there's often several easy ways to do, right? Which is the one that you should use? How do we make that decision easy? So the only really sane way to do this is through a single pane of glass, right? Some kind of coherent, consolidated user interface. So to this end, there's an exciting technology. It's already stimulated an active community and ecosystem of its own, and that's Backstage. Backstage is a framework for creating developer-focused user interfaces. And so this technology was created and open sourced by Spotify. It was contributed to the Cloud Native Computing Foundation, the CNCF, in 2020. And it's basically revolutionizing the internal developer platform space. It provides a framework for this single pane of glass UI experience, and it enables us to add capabilities that we want to provide through either ecosystem plugins or our own custom plugins. So I want to then bring this to an example of an internal developer platform. The point really here is Backstage together with Kubernetes really give you a foundation to build sort of a next generation internal developer platform. So as an example, I want to talk a little bit about VMware, what VMware has done, combining Backstage and Kubernetes and several other open source projects. So VMware, to begin with, it provides a wealth of experience in all of the layers that are necessary to sort of underpin a good internal developer platform. And it's pulling them together in a platform called Tanzu Application Platform. So it leans on Kubernetes and Backstage and various other open source technologies, as I mentioned. And it simplifies and enriches that developer, DevOps, and the operational experiences with this intuitive but powerful golden path that you can use out of the box with any compliant Kubernetes cluster. So, for example, I'll show you some screenshots first so that you can kind of get the broad scope of what it does, and then we'll do an actual demo. But as a developer, to start, you can use application templates to jumpstart an application. So when you start, you have not only the application scaffolding, but some sample code in there that shows maybe your preferred architectural patterns of your organization and code to start or some conventions. You can also, from your IDE, test small code changes directly onto Kubernetes. I'll show you that. You can then track your application on its path to production, and you can verify all of the safety and configuration features that are built into this default supply chain. And of course, this is the default supply chain. Things can be configured. You can also explore your application's running resources, and you can access logs, configuration, things like that. You can get a live view of the performance and health of your application at runtime. You can share, discover, and test APIs. And then you can explore, right, the vast array of internal applications and resources in your organization that are owned by other teams with this comprehensive view of the source code, the documentation, and even a security analysis. You can pretty quickly understand entire systems with visuals of, sorry, I went too fast. With visuals of the interrelationships between applications, right? And as I mentioned, where you need to detour from this golden path, this product does allow for pluggability and customization. So that said, we'll switch to a demo. I'm going to show you let me switch the screen over. Okay. All right. So I'll show you sort of a day in the life of a Spring Boot developer, or a developer, and then we'll go to the web GUI. So first IDE, and then we'll move to the web GUI. So basically, as I mentioned, one of the things that are included is, sorry, the clock has disappeared from the screen. So just give me a heads up, I guess, on time. So I mentioned there's these templates. Oh, wait, what? Oh, no. Yeah, I can probably do that. Give me 1 second. Okay, I don't know why it's not working from here, but I'll use it from somewhere else. So yes, I can make it bigger. Let me get there first. Okay, so those should load in the IDE. I don't know why they're not loading in my IDE, but essentially you can also come here. So the product, can you see that? Is that, can make this bigger too. So the product includes some templates, and of course you can add your own templates. But I'm going to start with, so for any particular use case, there's a starting point. So for example, just a simple web app. So I can, I have some configurability, but I might want to download this. So I generate it's kind of like going to start.spring.io, but besides the basics and the dependency management, you also have sample code. So let me go find that. Okay, so let me delete these other ones. Okay, so we'll go to the IDE. So yeah, that should work directly from your IDE, so you don't have to go through the web interface. But open. Okay, so basically we're given a starting point for an application, and you can see that this one happens to be a Spring Boot application, so you'll recognize all the structure, but on top of that, we also have some sample code. So we have a controller here that already has a mapping, so a way of educating and standardizing of how we write code. There's also another piece of code here where we're using technology called Tilt together with some portions of a project called Carvel to enable this iteration loop from your IDE directly to Kubernetes so that you can test against on a real environment. So let's see, so this is too small? Yeah, okay, let me do that. Does this work here? Is that good? Okay, perfect. Okay, so let's go to the terminal window. Oops. All right, so this tilt file, basically I can say live update start. So I want to get in this mode where the updates that I make on my computer are reflected live in Kubernetes. So of course, that's a little bit outside of, you normally wouldn't want to, if you have a container running in Kubernetes, normally you would rebuild it and redeploy. You're not going to do a hot swap of code into the cluster. That sounds like something that you wouldn't want to allow, certainly not in production, right? Not in a shared environment. So I specifically have to acknowledge that I want to do this. And so I'm saying, I have to, this is my conceding, right? So I have to manually add this line to the code to say, yes, I want to be able to hot swap code into a Kubernetes container on this specific cluster. So as soon as I save that, at that point, I've just saved the file. So Tilt is already recognizing any time that I save code in my IDE, and it's going to put that into action. So right now what it's doing, so this, I just took a zip file, unzipped it on my local computer, opened it in my IDE, and now I'm deploying that to Kubernetes, right? I'm not going through Git or anything, right? So what the product is doing right now is it's saying, let me take the code locally in the computer and send it over to the cluster. And the way that it's doing that is it's putting it into a container format, even though it's not, it's using a container registry almost as an FTP server, and it's moving that code over to the cluster, and then the cluster is going to grab that, unzip it essentially from this container format, and then build it into a runnable container and add the Kubernetes configuration to run it, and then start up the application. So this is sort of like the minimal deployment tool chain that has to happen for you to get an application into Kubernetes, right? So that's happening. You can see right now in the log file. Let me close this side. I normally work in IntelliJ, so it always throws me off a little bit to switch here. This is in IntelliJ as well, but I like it better. Okay, so you can see that it's building, right? And so there's already evidence here of a golden path for this very quick deployment into Kubernetes. So we're waiting for the container to be built. And in the meantime, we have something here where we can track that. It's still red because it's not finished. But basically, what we call this supply chain is that sort of CI/CD process, and it's really just minimal. At this point, it's just build, add the configuration, and deploy. So we'll just give it a second to finish. This is being, so as I mentioned, TAP is an orchestration of many open source technologies. So the particular technology that's being employed right now is called build packs. So if you're familiar with the Heroku platforms, Cloud Foundry, this is the same concept of a build pack, but sort of evolved for Kubernetes. And you can see image package, as I mentioned. Image package is that format that's being used in order to leverage the container registry as an FTP server to just move the code into the cluster. So that's, instead of calling it a container image, we call it an image package, just a way to move files over across a registry. So I think it might be done. So let me just see here. Let's check for it. Another application that's being, not yet, I guess. Give it a second. When the product finally deploys the application into Kubernetes, it does it on top of a runtime platform called Knative, which just really simplifies the deployment. Normally, if you're deploying an application to Kubernetes, you would create a deployment and a service, and you would have the basic functionality that Kubernetes offers. But if you deploy onto Knative, not only does the YAML that you have to write get simplified before the deployment, but Knative also offers many other features like auto-scaling, scale down to 0, things like that, and exposing your service. So it's a lot simpler. So let's see, we'll give it another second. OK, there we go. So the app is up and running. And we can test it. OK, so this is the default code that was inside of the code that we got from the accelerator, right? So that's sort of like getting you set up. Now, as a developer, what I want to do is iterate on my code. And that took a while, right? We wouldn't want to wait that long. So this is where this idea of hot swapping comes in. So now if I say, Spring 1, let's say at VMware Explorer. Let's spell it VMware Explorer. So now all I have to do is hit save, and Tilt automatically recognizes that I've saved a change. And again, there's no git, I didn't do a git commit, right? We're not going through another system. We're going straight from the code on my laptop, hot swapping that into the Kubernetes container. And if I switch over here, it's already done, right? I don't have to wait that long. So I'm really quick iterations against a real environment, right? So all that's from the IDE. Now, that's for my iteration cluster where I explicitly said I want to be able to do this, right? But now, how do I move the code? How do I onboard it into the actual supply chain, the actual pipeline that's going to do not these basic actions, but also scan my code and test my code and put it on an environment that's maybe staging, testing, production, right? So that onboarding process, so first of all, I have a copy of this application that I've checked into GitHub, right? At that point, you need to check into GitHub. So I have same app in GitHub. And this file called a workload.yaml file, that was, if I switch back to, this is the one that we just created. In config, there is a file called workload already. And it's mostly populated, but it doesn't have the URL of the Git repo where I'm going to check this in, right? So I've done that, and this is the copy in Git, and here I filled in the address where I've checked in this code. So once I check in this code, then because I was afraid that we would run out of time, so I've already done this, but what you would do is simply apply this YAML file to the build cluster. So there's a cluster that's dedicated to building, testing, scanning applications. So I would just do a kubectl apply of this file into that cluster. And that's all I have to do to onboard. Meantime, the platform itself, so this is now the UI. The platform is aware of that file. The platform sees that new workload resource in the cluster and begins to act on it. So if I go here, this is my workloads. This is the representation of the path to production. So here it is. Here's my Java web application. And you can see that here it's a multi-step process for deploying the application, right? So I have things like I got the source from somewhere. I got it from Git, right? So that's what it's telling me. So this is basically a subscription to my Git repository, and I only have to onboard once. Now, every time I do a Git commit of code, this particular resource, every few minutes, it's checking that Git repository, so any code changes will automatically be rerun here. So that's just, the application of that file is just the onboarding. This runs forever until you delete it. It has an action to test code. It scans the code before it builds the image. And then we see here that this will run that same build packs process to build a container in the same way. And then it scans the image, because when we built the image, we've added a runtime, we might have added agents, we've added an operating system base, right? So you want to scan that again. These things, if they fail, if they fail, then your pipeline would fail at that point, right? So if they fail at the source scanner, probably goes back to the developer, and it's like maybe, upgrade your dependencies, or there's something wrong there. As an operator, you have some control over how strict that should be, right? So if you have vulnerabilities that are found, you can say high ones cause it to fail, low ones are tolerable, things like that, right? And it can give you remediation action to find patches for CVEs. And when I showed you the screenshots, I showed you a security analysis. That security analysis is based on information that's coming from all of these scans, right? Because the system knows for all applications kind of how they were doing, so it can give you a complete picture of how secure your systems are overall. So we make the image. The next set of activities all have to do with configuration. So they all contribute little pieces to that YAML that's going to be the ultimate definition of your application. And finally, when that YAML is done, it gets written to a Git repository. So we have our code, our source code, where the developer did a Git commit of source code. And then at the end of the first part of this pipeline, of this workflow, we end up with an ops repository that has the definition of the YAML, right? So you can see here, it's using Knative, as I mentioned, for deployment, so the kind of resources as a service. This is ultimately what will get deployed to your production or your test environments. So that's sort of the one side of the GitOps. So now that we have that information in Git, now you apply it, so you have another activity that's watching that ops repo, and whenever there's an update there, like the SHA of the image changes, for example, that YAML will get applied to the cluster where you actually want to run this. And you can add multiple delivery clusters to here. We only have one, but if you had development, run your primary runtime, your backup runtime, et cetera, that same ops code would be applied to all of those clusters. So here we also see that we can get to the URL where the app is running. So our app is running, that's great. So that's the view into the path to production. So what else can we see? So here I can see, here's the whole organization catalog. So here you go to see your applications, but you can also see the applications that are being run by other teams. But if I go into my application, then I also have access to a little bit more information, right? Here I can see where the source code is. I don't have docs here, but I'll show that for you for a different application. You can see who owns this, and if you need to reach out to that team, then you know exactly who to go to and what contact information to use. So all of this is sort of contributing to ease of collaboration across teams. And then you have, I'll show you also, this one doesn't have an API exposed, but I'll show you that for a different app in a second. But I can see that runtime view, what's running right now. So here are all of the different Kubernetes resources that are running. And so I can choose, for example, which of these is actually running. So here, and it gives me this result. This is my pod. So then I can click on this pod and see all the kind of information about, for example, my log files, right? So here's my log files. Let me make this a bit smaller. Sorry. Okay, here are my log files. So you'll recognize in here that it is a Spring Boot application, right? So I can access my log files easily. I can change log levels. I can view my pod details. I can look at the YAML that represents that pod. And then I can, let's go to pod details. I can see all kinds of, I can see the whole hierarchy of Kubernetes resources. I can see a live view, so if I need to look at sort of memory utilization or CPU utilization, that's all here. It's also integrated because this is Spring Boot. I also have access to all of the actuator metrics. So anything that you might be looking for, health info, mappings, et cetera, all of that is exposed here. I can look at the environment variables for my application. So all of that information is really easy to find. So let me show you on a different application some of the other things you can look at. So here's an example of one that does have documentation. So if you want to learn more about an application, the same supply chain that built our application and deployed it, if you include documentation in your application, it will detect that and it will automatically publish the documentation to this site as well. So all of that can be integrated. And also, if you have APIs, the supply chain can also auto-discover those APIs and publish them. And then you have them here available as Swagger. And in fact, you can even go ahead and test them here. So you can either expose, share your APIs, or easily discover and test APIs that you could use from other teams across the organization. We looked at the accelerators, and really that's it. Then there's, of course, the security analysis that I showed you a screenshot of. But I think that's everything that I want to show you about the platform. So let me see if I had any other slides to wrap up. Any questions?
Aside the build pipeline, you get something like warnings. You can, for example, like platform team decide like this image is deprecated. You can set like warnings that this image will be deprecated in the future. It doesn't block the build pipeline, and the developer knows that the image will be.
That the image will be. So let me just open this up. So let me open it here. The application build process uses a technology called build packs, as I mentioned, right? And so the way that build packs work on Kubernetes and what's working under the covers here is that there's your source code, of course, that's one component for getting built into the image, and then there's the build pack that contributes the logic for how to turn your application into a layered image, as well as for example, for Java, the runtime and the OS bit. So, so those bits together, so for a question of deprecation, for example, like if it comes from something that's supplied by the build pack, let's say a new version of Java comes out, or a patch comes out, then what would happen is the operator is in charge of that supply chain. So those building blocks that go into building your application would be updated in the platform, and that supply chain, let me just start, I guess. That supply chain would notice the change, and it would rebuild your application automatically, even if you didn't check in source code. So let's say we're here, right? We're in this step. So if one of the, okay, so here's the supply chain. So that's the step that has to do with building your application. So if the build pack changes, meaning either the OS layer changed or the JVM changed and some operational bit, the supply chain the technology that underlies the image build, not only your application, but all of the applications across the organization that were built with that particular set of build packs will be rebuilt. That happens with the technology that's backing that image provider. Once that happens, the technology is there's another project called Cartographer that is basically orchestrating this whole workflow that will notice that image provider resource had a status change. And so then it will trigger the image scanner again, so the whole thing will rebuild. So it's not so much that you get a warning about future deprecation, but if there is any update to the bits that contribute to your image, even if you didn't, you don't have to kick off the workflow from the beginning with a git commit. It's sort of a living thing. So yeah, if anything to your image is updated, it'll automatically rebuild, and redeploy. Does that answer the question? So, yeah, is there? Then you'll notice, of course, yes. Yes. Let's start from the front. I guess we'll go front to back. Okay.
Is there anything for bringing back the linear processing to schedule the jobs considering the predecessors as well as the successors?
Considering the
successors of the previous jobs.
I mean, so it's like a Spring Cloud data flow, sort of. I mean, this is really for building and deploying applications, so I guess from, unless somebody else here can help me answer that question, but I think if you're building your own transformers for Spring Cloud Dataflow, then those are things you might want to build, test, and run. But otherwise, Spring Cloud Dataflow sort of manages its own runtime. There is a Spring Cloud Dataflow for Kubernetes, but that's, it's not, I don't know that it would be integrated with this supply chain in that sense. Yeah, does that answer the question?
Yeah, I mean, I'm more just talking about the scheduling of the jobs.
Oh, like when they're actually running? Oh, okay. So this supply chain, as you can see, so when we onboarded this application to the supply chain, we used these labels to tell the platform what kind of supply chain to associate with this application. So this is a web type application, and that's why it chose this particular supply chain to handle it. So if you needed to, for example, process a different kind of application that at the moment that it gets deployed to Kubernetes, it shouldn't be a Knative service, it should be a job type resource, right? Yeah, then you wouldn't use this supply chain. You would either use another out-of-the-box supply chain, or you can create your own, and so it would process that application in a way that by the end, the YAML looks the way you need it to look. Yeah, you're welcome. Yeah, I got you too. Yeah, sorry. Well, you raise your hand first, so let's do the back middle first. Oh, we can bounce. Okay. Oh, I don't think that there's a Tanzu Application Platform certification, but there is a website called Tanzu Academy where it's free, and there's a lot of stuff you can learn about Tanzu. Do we have a certification? I don't think so. It's in process. There will be. So, yeah, sort of. Okay, so I heard a few different things, but so one thing, when I mentioned plugins in particular, I was referring to plugins into Backstage. So Backstage is the technology to create this user portal, and it works based on plugins. So this functionality that you see on the left, like even like the documentation or the accelerators, all of this stuff, right? This, like showing these supply chains here, that is a custom plugin from VMware that's being added to Backstage in order to add that to the portal experience, for example. So that's the context in which I use the word plugins, but you did mention that like the example of the Angular, et cetera. So those are templates for applications. So we do VMware includes some default templates. So that's just if you're going to bootstrap a new application, you can come here and you get fresh code that has a little bit more than just the dependencies. These are really just being pulled from Git repos. So in your organization, if you have different architectural patterns that you want to standardize on or encourage different code, different conventions, then you can create your own Git repo with that sort of like base template that you want everybody to use, and you can publish it here so that people can easily find it. So these are these accelerators. And then as far as like things like, I don't know what the source of the question about Kubernetes or Docker support came from, but Yeah, exactly. And so even this, when we go into the runtime of the application, you can see that Kubernetes, when we go into what's actually running behind this application, you can see these are Kubernetes resources, right? And if we go into the pod, you can see the whole hierarchy from the workload that we apply to onboard the application down to the Knative service that's running it, down to the pod where that container is actually running, right? So Kubernetes is running in the background, and the platform is going into Kubernetes to extract the logs from the container and things like that, right? From the pod. So it is integrated through this plugin in Backstage. That uses the Kubernetes information to surface the information of interest to developers. And then, I don't know if you mentioned, if you had a question around Jenkins or something, but.
Yeah, I think you answered. I just need to do more investigation, but I think the absolute model plan, we have a traditional environment, where we're using, open source tools.
Yeah.
And I'm trying to see exactly where does it fit into the scheme.
Okay, yeah.
I think the perfect idea is that if you have to deal with the DevOps team, you have to necessarily deal with so many different applications.
Yeah. For sure. Yeah, I mean, it would be interesting, to sort of do an analysis of what you have today, and if you, because there's areas where like this might just be simpler to move to, and then areas where you've invested a lot and it's hard to leave what you're doing, and then maybe you would find a way to make them work side by side and sort of complement each other, like keep doing this in your old environment and then find a way to sort of, marry the two somehow, or at least as a transition. But yeah, I'm at the VMware booth, happy to have this conversation, as long as all of the folks at the VMware booth would be happy to kind of dive into that. Yeah, for sure. Yeah.
Yeah, question around, I see all wonderful automation around app deployments and stuff. I can define my app and get it deployed. Now, but does that extend to services as well, like independent? So let's say I want not just to commit and then my app gets deployed, but I want to be able to change something in my repo that says, hey, I need an Amazon S3 bucket or a Postgres database or
Yeah.
Can you automate, can I provide a template that knows how to stand up the database and apply my flyway migrations and stand up the S3 bucket and then do the Amazon permissions or whatever the cloud provider is.
Yeah, and make dinner.
It's the service automation and the gluing my app to the service.
Yeah.
Without having to click through a manual console, but I want to drive it from
Yeah.
the file and repo to.
So the platform includes the ability for, the platform includes the ability for operators to create instances of services that you might need, make them available. And then what you want to automate is your application binding to them, right? So sort of like there is.
I get that part. I want the developers to be able to stand up this service. So.
Yes, right. Well, so what the developer declares is that they want, for example, like a claim on an existing RabbitMQ or a claim on a database that's running, right? So at least that's the way it works on this platform. So the developer just includes that claim information when they deploy their application, and then the platform through the service bindings will automate that so that the application, without the developer having to obtain credentials or stand it up, it'll just sort of orchestrate that, enable that binding of the application to the back end. So as far as providing that infrastructure to the application to have the database, that is automated through the pipeline, through this idea of service instances and developers dynamically making claims to them. And then as far as like something like Flyway, that doesn't change here, right? Like as soon as the application stands up, that is it uses the binding to connect to the database, and then Flyway will do its thing. Yeah.
But is there a way to automate standing up the service as well, not just deploying it?
It doesn't, that's not fully automated. Yeah, there is a little dependency on the operational team establishing these services in the background. Yeah, and then the claims are managed. Yeah, but the claims are dynamic, I guess. Yeah. Sorry.
Follow-up question regarding the first question about Synapse and deprecation, etc. So I assume that KPAC or similar technology is being used there, but then the follow-up question is, we often deal with clients that have their own base images, and they are forced to use their base image because of internal regulations, etc. How would you?
Can you do that? So keep me honest here. So what's backing that technology is it's Tanzu Build Service, which is a commercial offering that is based on KPAC. And within the commercial offering with KPAC, I mean, I know there's been a lot of discussion over time about enabling people to add their own base images. I don't know where KPAC as an open source technology stands on that, but from a commercial Tanzu build service perspective, which is what's here, I think we do allow it, right? Vinay, Dan, yeah, yeah. So yeah, as long as the commercial one does support it, yeah. So you could, yeah. Any other questions? All right. Thank you. Thanks so much. I really appreciate you being here. Cool.